Hey everyone, welcome to another Common Lisp study group. I'm your host, Ron Vadum with Atlanta Functional Programming. Sorry for the lateness today, or our beginning, but just a couple of things that was preventing me from getting started a little earlier. Today we'll be discussing the unixsockets library, a library that's available inside Common Lisp to allow you to communicate and create as the name suggests, servers that ends up using Unix domain sockets. Our agenda today is that I'm going to kind of give you the case for Unix domain sockets because I'm sure most of you who are aware about Unix domain sockets may have not had direct experience with them, although you may be using them all the time, especially if you're on Linux, because there are several servers and daemons that leverage Unix domain sockets. It's one of the address families inside the sockets API that's often used for interprocess communication inside Linux and any Unix derivatives out there, whether it be BSD, Solaris, or so forth. It's been around since the late 70s, has actually as part of the original sockets API implementation, and it actually revolutionized the way you do interprocess communications. A lot of other additional interprocess communication mechanisms got put into the Linux kernel shortly after, things like message queues, systemd message queues, and eventually POSIX message queues and its ilk. But Unix domain sockets is one of those that are often more used than the others, mainly because of the fact that it ends up leveraging the same API that you would normally use if you wanted to switch over to using TCP/IP, because it's a different address family, same API. Today we're going to be looking at how to write a basic server within Unix domain sockets. I'm still a little unfamiliar with some of the portions of this API, although I am familiar with Unix domain sockets, so we'll be learning together on this live stream. To begin with, I'm just going to go quickly. I've created earlier a simple project that allows us to actually get started. And I'll quickly show you the ASD file here, but let me first load this into my REPL. So go up, let's see here, let's pull up local projects and sockets over here. So we're going to be, in our discussion today, just mainly creating a very simple project that's kind of an echo server and echo client. Although we don't necessarily need to do the echo client so much, we might be able to leverage other existing tools out there that allows us to hook into a Unix socket server. There are a couple out there. I think you'd have to specify the address specifically to say like netcat, and then it would actually allow you to go ahead and hook into your Unix server, much like you would with a TCP server and so forth. Let's do a little bit more setup here. Let me just double check something. Actually, let me do this. Shell. I'm just mainly checking up something on NC, which might be able to help later on. Okay, this may not help. We'll see what we can do. Okay, we'll whip up something if we need to when the time comes to when we need it. So let's go ahead and open up our main function here, our main Lisp file. And let's begin. So the unixsocket API, as I mentioned earlier, is essentially an extension, an address family that's part of the sockets API. Unix sockets, as I alluded earlier to, are very specific to Unix and its derivatives. They are essentially domain sockets that are implemented at the kernel level that allow you to connect between and create uh, sockets for communication, bidirectional sockets for communication between two processes running on the same machine. So in many ways, you could think of these as being a lightweight version of the TCP protocol. The differences is mainly, for folks who are unfamiliar with it, is at the Unix domain level, I think it's technically, they're both TCP, IP. I think Unix domain sockets are at the same level as IP, not necessarily TCP, because IP requires you to have the machine addresses that you're going to be communicating with, whereas in this case, you're going to be running on the same machine. The API is very much similar if you're using other languages like, say, C or C++, where the sockets API originated. Specifically, when you are creating a socket, you'd use the same socket initialization code that you would with TCP. The difference is you would end up using something called AF Unix versus AF INET, which is a difference between a Unix socket and a domain socket at that level. At this common Lisp level, the reasons why we're using a different socket library than, say, usocket to actually go and use our Unix sockets, it's mainly because usocket was tailored around TCP IP and its specific quirks and nuances. unixsocket, though, does provide a similar API for creating, accepting connections, sending and receiving, and so forth. As far as I can tell from the documentation, the API is fairly simple. It has connections, accepting, being able to listen, and things like this. To get started, I think the easiest thing to do is to first go ahead and write a simple function that would, go ahead and start a Unix socket server. All right. And what this is doing is you're providing probably like an F name to it, because Unix sockets kind of behind the scenes end up mapping themselves to a file on the file system, much like you could think of it much like a pipe inside Unix. The difference being is the APIs for reading and writing into the socket are different than the pipes, and pipes also have some optimizations behind the scenes. To create such a server, and it's very simple, unixsockets has something called wit's unixsocket, which is what we're going to be using. Behind the scenes, there is something called a make Unix socket. Looks like we don't need this. We just need to use a function. Hold on. This guy, don't show this. Again. This right now. There's a lot of stuff about this specific thing, the library, that I'm still kind of learning. So, like I said, we're gonna be learning this as we go along. One of the main reasons why I think this is a particularly useful library to have, and something that I'm kind of glad is available, is mainly because the fact that there are several daemons that are currently out there that you can leverage this once you know how to hook into Unix. that use Unix sockets behind the scenes for inter-process communication, mainly things like Docker. If you're running Docker on your local machine, you can hook common Lisp into it using Unix sockets and use the Docker web API directly to communicate with your data. And this will give you some abilities to write some higher level utilities on top of such a tool. And there are many other examples too as well that leverages this. So let me go ahead and look at what and let's pull up this. And let's see what unixsocket. Unitsocket does. SCK. And let's see what happens here. And nothing happens. Let's see what happens on bind protect. Close unixsocket. Let socket equal function. So do we need to actually go and call unixsocket, make unixsocket directly? Probably. That's probably why I have to do this. Okay, let's see. unixsockets, make unixsocket takes a path. Yeah, that's what I thought. Okay, that's the reason why I just didn't see that. So what this is doing here is you do need an f name, like I said before, but I thought it was wrapping it around inside the function, but actually what it's doing instead is it's actually allowing you to take specific function names that you may want to, like, create, like, for example, you might want to, for whatever reason, wrap this guy in your own API that, and we could do that too. Defun make unixsocket. We'll just call it make a local socket for now, and then we'll take a path, and then our queue size, and that's represented as backlog inside of unixsockets as API. And we just do make unixsocket f name, and you can see here that the backlog here is set up to being the maximum number that you want your jobs that you want or connections that you want it to hold. You can call it, yeah, we'll call it queue size because that sounds more correct than backlog. So now we have that. Then we have our make local socket. Oops, sorry. Make local socket. F name. And we're going to say queue size is going to be 10. Okay. That means we're going to only have like 10 connections available. Actually, we'll try to even make this even 1 just to make things a little simpler for ourselves. Alright. Now, just like any normal socket server, if we expand this, you can see that what it's actually doing is it's going to actually finally close our socket before actually ending out getting out of the unwanted protect. So this is just going to take all of our connections. We now have this socket connection that we could literally grab, and we could get started on writing a very quick thing, just like we would normally do with any Echo server example. We can actually accept Unix connections and then attach those to, let's say, either a thread, or in this case, we'll just make it blocking. We'll have a single process that will take one connection at a time. This is normally how you wouldn't want to write a server, but when you're getting started with an API, you always want to start with the blocking, try to get everything kind of structured out, and then, expand out. So this is kind of the same approach that I'm going to be doing here. Let's see here. We can do now. We can accept the Unix socket, but what does it return? It's kind of like an interesting question. So does it return a socket? Let's see here. When in doubt, go into the code. Actually, let's go and do something first. Let's look up accept unixsocket. See. This takes a derived type, source file, unixsocket.lisp. Okay, so let's grab this here. And, sorry, not that. Not that. For some reason it didn't copy it. As well, local projects, software. Let me do that again. Okay. So it's almost kind of useful to keep around some of these things, especially with Unix sockets, just because it has, since this is like a CFFI wrapper around the sockets API of your underlying Lisp, Linux distribution, it's good to know what's available and what's not available with the API, and look at what's exposed or not. If you have any doubts, usually this is kind of what I tend to do. I go into look into the source code to see what the signature is and how to read stuff from it. Except unit socket, but wait a second. There's a close function to attach to it as well. Okay, and then it has a buffer. So unixsocket itself is a class that's actually wrapping itself around the unixsocket API, because for those who aren't familiar with the C implementation of sockets, socket APIs, may have used sockets using objects in your language of choice, whether it be Python, Ruby, Java, or what have you. Or even in C++, they now have some way of actually allowing you to do sockets using objects. I'm forgetting the library that allows you to do that. In normal sockets, the socket itself is a file descriptor, okay? Whether it be TCP or Unix or what have you, okay? What this is doing is just abstracting it out into a socket object, much like the same thing that you noticed if you used unsocket. The difference is unsocket, the close function would just simply close the file descriptor. You could, in unixsocket, not only do you have to close the file descriptor, you may have to delete it off the file system, because it's not a temporary handle. It could often be a handle that is fixed inside of the local area. let's see here. Make unixsocket accept. What is it doing? Make instance of Unix. Okay, so it is actually grabbing the connection, and then we could read and write from it. Excellent. Do we need to call listen though? Is the question. Make listen. Hold on. What is it saying? It says listen. Let's socket make unixsocket bind. Oh, this is nice. Okay. So this is something I just learned. So in usocket, you don't necessarily with tcpsockets you have to actually explicitly call listen to get the server started. Here, once you bind to the socket, it automatically starts listening. I guess that's a good thing. I don't know if that's necessarily a great idea, but it looks like that can work because of the fact that you are talking to an actual file path that's available. But starting and stopping the server gives you more flexibility. And you could certainly, it doesn't look like there's a way of setting that up here. But, I may be just losing it in terms of what it can do. Actually, let's try this example here. So, just to show you what happens when you do this, let's create a dumb make unix. Oops, sorry. To unix sockets make unix socket /temp /blah cl unix socket, and we have the default backlog, and we end up getting this. If we go and look at this, we'll see that this is nothing more than a closure around an initialized instance that keeps track of the close function is nothing more than a closure that keeps track of the file descriptor that's available, and then it goes and closes it off when you actually go and call close. That's what it just fun calls it behind the scenes. If we look at the shell, which we had earlier, and we go into our temp directory and we do an ls and grep our cl unix socket, you'll see that it is there. This is the file descriptor that now everybody can connect to actually go and make connections. Now, obviously, I'm not going to keep this one around. I will go ahead and close this guy so we can actually do our no, sorry, not that. I have to call unixsocket. Close unixsocket. I'm gonna probably have to. Okay. My apologies, folks. I am using I'm shelling into a socket for this demonstration. So some of my Emacs keyboard shortcuts aren't working as I expected to. So what was I doing earlier? Yeah. So this is now that. So I should be able to say unixsockets : close unixsocket on Okay, so now if we go and look in our shell, okay, ls/temp grep, you'll see that it's still there, but it's no longer available for reading and writing. Okay, so we now have this Unix socket. We can now go and grab something from its connection again. Usually you'd want to have multiple of these, but I'm just going to use one at a time. And we're just going to make a dummy server that will take in one connection, close it, and then exits itself. Okay? Really dumb example, but it works. Now, we'll do let client equal unixsocket accept from the socket that we've just created. Okay, so now we have our client, just like any other TCP client. Okay, we can grab something to this, and we can now read and write from it. All right, this is a bidirectional. This is not a read-only socket. It'll allow you to read and write to it. The way you read and write to it requires you to first. There's a couple of calls that you need to use. The first one is go back here. It's going to be, it's not read. It is initialize instance, or is it? Aha. So the unixsocket object allows you to read and write to this unixsocket, much like any object with some accessors. To read from the accessor, you can do to read from the socket, you could just use the buff object, the buff accessor object, to actually go and grab the connection, and then read from it. Interesting. Okay. Sorry, I'm getting. Here we go. So, to read from it, you could just simply go and say print buff from unixsockets, because this is an exposed exposed object. Doesn't look like they've actually implemented that one piece the way I expected to. What I'm doing is I'm looking at the package to see what did they expose here. So they have make unixsocket, close, connect, shut down, unixsocket stream, accept, and with. So maybe they want you to use unixsocket stream instead of the buff, because that's a Flexiio stream. That might be the reason why they wrote it this way. Okay, let's go and check that out. Let's try that out. Instead of using this, because that's obviously disgusting. You don't really want to do that. Okay. just to show what this is, what this does, let's go ahead and let's start our Unix socket server. Oh, right. I'm not in the same package. Let me do this. Okay, now start. Our name is going to be I'm going to use the same one that I created before. And printing the following condition. What is this? Socket error. Socket error. Failing to address. Okay, it looks like I don't have access to actually reuse the socket. So let me change this. I'm just going to get rid of it manually. Okay. So now we have a socket that's running, but we need to have a way of connecting to this. So one way of doing this is obviously if you had another program connecting to this Unix socket, you could certainly do so. What I'm going to do is I'm going to open up another REPL. Start a new one. Okay. So now that's running, and I'm going to go ahead and open up Unix sockets directly. And if we're a client here, what we could do is we can now use connect Unix sockets. Here we're not doing anything. We're not sending stuff to and from it. So, but this will at least show you kind of the communication of connecting to the server, getting it accepted, and then having the server shut down. Here, so let's do connect to Unix socket, and we need to have the path to it. This is the main thing that you should remember. One thing about Unix sockets is, since we are communicating with file paths, having the paths ahead of time is kind of useful for, especially if you want to connect to it later on. So here, since we know our Unix socket, we could go ahead and do that. And when we do it, you can see that it closed, but we got a socket back here. Technically, this socket is still open, if I'm not mistaken, so we can close it now. And this is also now closed. So, one thing to note is notice that when we're closing the Unix socket, we do get a return of a -1. That's coming from the CFFI handle of closing it or not, versus the C function itself being passed into Lisp using CFFI versus the actual API returning it. And you can actually look at that when you go look at the Lisp file itself here, as we saw earlier. Let me see if I can bring this down a little. Okay. And let's see if I can do this. Okay. And we go to close Unix socket. As you can see here, all this is doing is actually, I take that back. It looks like this socket is actually setting it to the -1. It's not the func call. Why would they want to do it -1 though? Okay, that's fine. So we now have the ability to open up a Unix socket, close a Unix socket, set up the queue for our server if we're trying to write our own Unix socket server on the server side. Okay, That's through the backlog argument that you saw in the constructor, although I named it queueSize for the sake of mentioning what that actually is. That's kind of your connection queue, right, of the number of waiting connections. The next thing, obviously, that we need to talk about, though, is something that's more important, which is we're able to connect and we're able to accept connections, but we haven't actually done anything with those connections. Let's write something into that connection now. So the way you would do that is you would first have to convert using the exported definitions. Now, before, when I was telling you about using buff, you don't necessarily need to use buff. What you can do is internally, what they've done is they're using Flexiio streams, which is another third-party API that allows you to essentially use the stream API, the normal common Lisp streams API, to read and write from it. So if you wanted to read an integer or write something from it, you could certainly do so. And that's what we're going to use for this. We're going to first take this client, okay, we got this client's object, and what we're going to now do is we're going to actually go in and call unixsockets, unixsocket stream. Actually, let's go ahead and do this way. Let's do this. Okay, 1 second. I have to do not space. What is meta x? It's nope, that's not it. Weird. Why did that not work? My apologies. Let me see if I can do it this way. Okay, fine. We'll do it this way. It's a little disgusting, but that's fine. Okay. We're going to rename this to client stream. What we're going to do is we're going to actually wrap the accepted classes into a sockets, unixsocket stream here. Okay. Now, what this is doing here is all it's doing is again, it's making a Flexiio stream that adheres to the streams API that's already available for us inside Common Lisp. I will talk about Flexiio streams in another episode, but really, in a nutshell, all you need to know about right now what Flexiio streams does is it allows you to be able to essentially leverage the streams API for like read line and format and stuff like that directly from within Common Lisp. They create what are called virtual bivalent streams for you to read and write character data in various codings, and it's a much more efficient way of doing some of the stream stuff than what is currently available. Well, part of which is not available actually in Common Lisp directly without such a library being used. Let's see here now. So we're able to read. Let's see if we could actually use this now. Because all we're doing is now we're going to go and then leverage this to actually grab some data off of it. Okay. Undefined. Wow, dang it. There. Now let's do this again. Okay. Oops. I'm in the wrong one. 1 second. I have to close off one of my Lisps right now. Okay. Let's do this again. Okay. This. Okay. So now this is done. Client stream is never used. Well, of course not, because we haven't actually done anything with it. All we're going to do is we're going to print out what we read off of the client stream. Okay, so this is going to do a blocking read on the client stream until it gets something, and then it should actually read it in, has a normal character line, and then print it out. Okay, that's all this is doing. Let's start the server. Oh, right. Sorry. My apologies. Gotta remember. Start Unix service /temp unixsocket, which means I have to go and clean this up one more time. One thing that I will do is there's a way of actually setting this up so that it'll always remove the file name using unwind protect, but I'm forgetting right now what is the common Lisp remove file path. I know it's a way through like not just close, there's also remove. Remove file object. Deleting directory, closing. Right, we could use just UI op to actually go do that, which is already available for us. Let's do that. Okay. What I'm doing is I'm basically writing an unwind protect on this guy to always remember to do this. There we go. Okay, UI op, remove, delete, file if exists, fname. Done. Okay, so now let's do this. This is probably going to complain for the first time because it's failed to bind to the address. And that's because of the fact that we didn't remove it last time. So let's go ahead and remove that. rmtemp cl unixsocket. Okay. Let's try this again. So now this is running. So let's open up another connection. Start a new one. Okay. Now here we again have to load up unixsockets. Okay. Notice we still have not actually closed the socket yet, all right? We have just merely, it's still waiting for input, okay? Now, what we're going to do is we're going to go ahead and make a Flexi stream of this guy. unixsockets. Okay, so now we have a Flexiio stream. Let's go ahead and write to it. Format. Destination is our previous one. Our control string is just going to be hello world. And we close it, and you're going to get this following error. What is it wrong? Has no suitable stream to this method. Okay. Maybe I'm writing to the side the IO stream wrong using Flexi. Okay, in memory streams. Okay. This is. Did I forget to put some defaults into the Flexi stream? That might be the problem. Let's see. It is. Yeah. Okay. I see. I'm gonna have to close this socket. And try again. Close. End of file. Well, yes, of course it's the end of file. Because of the fact that I didn't write anything. Which means I have to go and load up this guy again. Start it. Which it has. Now, let's go ahead and reconnect. Which we have. Now, what we have to do is we have to do. It says make flexi stream, make instance internal stream socket, which is what it did. Now I should be able to write to it, but I did not use the right thing. Okay, let me just do another thing here. Let me use write line instead. Okay. Okay. Now write line hello world. And then let's see what happens when I call flexi stream out of it. This should work, but for some reason it's not working the way it's supposed to expect to. Let me try something else. We're going to restart the server again, guys. Sorry about this. Okay. Okay. And go here one more time. Connect to that. Instead of doing this, let's see if I can actually write directly into the socket. Because we might end up having the same problem on the server side too, if I can't do read line from it. Let's see here. Let's do write line. Actually, what am I doing here? Okay. With unixsocket, accept, make unixsocket. We have a listen, we have a p-check, we have a character pointer, and we have accessors to this. Package.lisp says that unixsocket is connect, close, shut down, unixsocket error expecting with. Let's see here. Okay, it takes a backlog, it takes a listen, that's fine, this is all good. This is okay. Shutting down the unixsocket. Method stream read byte. Ooh, wait a second. What is this? Calling unix received until that. This would evolve. So we want to avoid this. Not true. Okay. There seems to be a actual API here that is not exposed for the Unix socket, but specifically for the internal stream. Looks like we do have to use Flexiio because it creates an internal stream, but what's returned by the internal stream, we have to use, I think, their API for stream read byte and write byte, which they did not actually expose. Weird. Okay. Let's see why this is stream read write byte. Where is this being used? Who calls this guy? Okay, calls who does not. It's not reference. No references found. Okay. Don't know if I should do this, but let's see what it would work or not. Okay, let's try that. So for this, we're going to have to close it again because we're going to have to do a little work to actually make sure that this is all working. Yeah, let's do that. unixsockets, close unixsocket, error here. I'm going to have to close this bottom one. Quit, yes. Okay, yes, that one. And in here, we're going to have to probably get the byte stream before we can print it out. Bytes. And what we have to do is do unixsockets. And since this is an unexposed API, we're going to have to do stream write byte here. And the reason we can't use any of these other ones is they're not overridden. But we shall see if this works. Definitely. Read byte. Write byte. Oh, wait. This is read byte. Client stream. Okay. Let's see what happens here. If we actually get something from it, then we have this is just going to print some integer around it because of the fact that we're not actually we're not actually doing any sort of conversion. All right. Oops. Okay, there's a question here. Isn't a queue size of 1 equal to 1 char? My understanding is in the Unix backlog, that is the number of open connections. I don't think that's the size of the actual buffer. But I could be wrong. Let's go and take a look at that. Here. make unixsocket. This is into this socket. Listen. So we have to go in here to, what's it? Let's man listen here, because it's going to be the same on the backlog. We're found maximally of pending connections. So that should give you what the answer there. Folks watching, man listen, although it says BSD there, it's going to be the same for Linux. If we do shell here, might hopefully do not screw this up. Man listen will not give you everything. You can see right here, the backlog argument defines the maximum length of the queue for pending connections. When a connection request arrives, it will receive an econ refused. So I'm basically saying that this is a server that only will accept one connection. It's a really contrived example, but it will illustrate the point of actually interacting with the API. Okay, so this is written. I'm not entirely sure that it's going to like this. Let's see what it says. Warning, undefined variable client stream. Oops, did I? Oh, this is not a let star. My apologies. This should be a let star now. Now this all works. Clear REPL. Okay, so this is now good. Let's go ahead and start it. Start on our socket. Now we're going to start another server. Okay, and here again we're going to call our unixsockets API, unixsockets connect, and we need to specify the socket. Now we have that, we can go ahead and use what they're suggesting, which is make Flexiio, unixsocket stream this. Now that we have that, we can go ahead and do unixsockets write stream write byte some integer. Let's say 80. Okay. And you can see here that it is going to be sending 80 to it, and it closes out the socket stream. Now, one thing I'm a bit disappointed about in this library is the fact that it didn't implement the other APIs. I'm wondering if we could just use, since stream write byte, stream read byte is available as part of common Lisp. I'm wondering if we could just use the streams as is, because then, obviously integers don't really make much sense. If you'd want to do something a little bit more different with the other APIs, but let's see if this works. Let's start the server again. Okay. Now let's connect. All right. We got another connection. let's go ahead and grab our socket stream. Okay, we have a socket stream now. Let's go ahead and stream write string into the stream hello world and see what happens. And as expected, it's going to cause this issue. So this is kind of what I was expecting from what we were seeing earlier. Right now, the way it is currently written, you won't necessarily know if you're using Unix socket streams what it is that you are writing to the Unix socket. This looks a little more incomplete than I thought it was. I thought it kind of at least implemented some of the basic things for the, and it certainly did for the creation, closing, and accepting pieces, and it abstracted away the majority of the Unix API, but it didn't implement and complete implementing the writing of abstractions into the socket. So that's one limitation of this library. But it has all the necessary pieces for you to certainly build off of what it's already done. And it is a step in the right direction if you want to use this for inter-process communication, just because honestly, one of the problems with using inetd or using tcpsockets locally is although each individual operating systems tend to work the hardest to make sure that if it's localhost that you're doing, it tries to avoid a lot of things from, say, for example, doing more stuff at the kernel level than at the application level. But you still end up having this envelope of going from user space into kernel space related to the payload getting additional pieces from the application layer down about information about itself and so forth. That's actually just avoided if you're using Unix sockets directly as a form of inter-process communication. That is something that I was trying to essentially illustrate here, but it looks like this Unix, the sockets API is not as complete as it should be. But again, like I said, pull requests are welcome, and the skeleton here is very much robust enough for you to actually quickly add that functionality for it, especially since that they gave you in this abstraction, this internal, what the heck, where am I? Oh, sorry, I have to close out some of these guys. Okay. And yes, okay. Specifically here, if you look at this, the fact that it's leveraging Flexiio, I think is definitely a step in the right direction in order for you to actually leverage reading and writing to this API. Although the fact that we still needed overrides for some of the stream methods is a little disheartening. But it is what it is for right now. I think this is a good starting point. I think this library certainly needs a little bit more work in order for it to be production quality, but it is definitely something to take a look into. This is something I'd recommend some folks to do it. And again, this is especially for those of you who are using unsocket, in which unsocket had unixsocket support, which it currently does not, as far as I can tell. And those of you who know about unsocket, if you know that there's a way of using unsocket for AF Unix, let me know so I can correct myself. As far as I can tell, and from the API, I have not seen a library or an example or a way in the API to actually explicitly say not to make a AFI net socket instead of make an AF Unix socket. So that's it for today. That's all I had. Are there questions? Okay then. Well, if there aren't any questions, I'll see you guys next week. And those of you, just a reminder, tomorrow, 1:30 to 3 Eastern Time, is our Haskell study group. We will be continuing our exploration of Haskell, starting with currying and polymorphic functions and moving our way towards some additional information about types. So